Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shops. I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is body electrical systems. You might think body electrical systems, windows, doors, and lights. How complicated can it be? But if you've had to diagnose one of those systems, especially on a newer car, they can be kind of complex. If we take a look at this wiring harness, as I said, I worked on a lot of electrical problems at Subaru. And yeah, the harnesses kind of look like that. There's a lot of connectors, there's a lot of wires, there's a lot of modules, especially on a modern car here. So why are we talking about body control modules? Because it's not just relays and fuses and switches anymore. There's a lot more involved with it. And as I said, it's just gotten a lot more complicated. So we're trying to hopefully maybe demystify and give you a few tips and tricks how you might be able to help yourself if you need to diagnose a body electrical system, and hopefully save you some time when it comes to doing that. So if we go back in time, 20 years, because it is well over 20 years now, since 2022, but 2001 Chevy Tahoe, right? That was our old demo vehicle in the tool for the longest time. But that had a body control module back then, 20 something years ago. And on that body control module, it uses 57 pins. So it's 57 individual wires going in and out of this. And it connects to 11 different systems. So things you might expect, like door locks, electronic power steering, even back then, 20 years ago, it had it. Power distribution, interior and exterior lights, horns, headlights, computer data lines. That's where we're starting to get into a little bit of networking there as well. Anti-theft system and the warning system as well. You can see there's not a lot going on. It's one page. It's all over there. We got a couple fuses. Let's see, 1, 2, 3 fuses feeding it, and then a couple different switches feeding it, and so on. So not a lot as far as complexity. It was still, you still had to go through a diagnostic workflow and all that to try and figure it out, but not as complex as we're going to see as we progress. So that's an 01. 15 years later, we get to a 16. And you can see that as 2 pages. And 155 pins on this module are being used. And if we look, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 different fuses to supply power in different ways to this module. And then, of course, there's some relays and switches up there, and a lot of different systems that we come, right? So we had what do we have before? We had 11 systems. Now we have 18 systems here. So things like door locks, electronic suspension now on this. We talked about that a few weeks ago. Power distribution, interior and exterior lights, horns, headlights, etc. Anti-theft door locks, ABS it connects to now to get input from there. Shift interlock, wipers and washers. We'll talk quite a bit about that as we go through the night. Transmission, cruise control, starting and charging, trunk, tailgate, and fuel door, seats. Think about that. Body electrical and seats. I have heated seats. I have cooled seats. I have seats that vibrate, especially on this Tahoe, right, with the ADAS. It has a vibration module in there as well. So that's all considered body electrical too. And then, of course, the defogger at the end as well. And then we get to a 2021 Chevy Tahoe. Now, this was kind of interesting looking this up. It has 126 pins, so 126 ins and outs, but that's less than our previous from 6 years ago, right? Or 5 years ago in the 2016. So we have fewer fuses feeding it, so 4 fuses instead of the 7 or so we had before. But you'll notice with the 126 pins, what it did is it really reduced the workload on the module. It doesn't control as many things because there are now sub-modules as well. So it'll pass on the duty to control, say, the headlights to the headlight control module. So we won't have to necessarily have as much direct connection to the body control module. But the body control module is still, by and large, the brains of the operation, right? So this is your main hub of the vehicle, so to speak. So in this case, it's 24 systems. So we had 18 systems, now it's 24. So a lot of the common things, now also the cooling fan system, which we didn't have before. A lot more computer data lines. So we have like 9 LIN buses on this, a bunch of different, a couple times it's hooked up to CAN as well. So a lot of networking, like I said. And then the seats, again, starting and charging systems, ABS, navigation now too. A lot of these things are connected together, interconnected. So if one part fails, we could have a failure in another module somewhere that we'd have to chase down. So with this complexity, of course, it would seem that it makes it a little more complicated to figure out if we do have a problem in there. And this is where we have to think about, we can look in our wiring diagrams. We can also look, a lot of manufacturers will publish input and output charts as to what's going on in the module. So if I'm checking a body control something or other, windows, doors, lights, things like that, you got to remember I have inputs and I have outputs. So things like switches, sensors, data pins coming in. It's going to catch data off the data line. Maybe it needs a vehicle speed sensor, maybe input. Maybe it needs a transmission range input, something like that, coming into the module. And then we also have our outputs. So motors, lights, window motors, wiper motors, headlights, marker lights, and data. It'll send out data voltages, network voltages out over the data lines as well, right? So we have to think about, what am I working on? And what are the inputs and the outputs that are associated to this thing that I'm working on, whatever it is. Because it's not like this old school. This is that 2001 Tahoe. We went back to the left rear window mode, right? So we need to kind of change our thinking a little bit from when we would diagnose this. When we would diagnose this, well, we got power, we got ground, we got relays and a switch. Where are my failure points? Power, ground, relays, switch. Not a lot of messing around with it, right? I can check my power, I can check my ground easy enough. I can make sure that the power is getting out and in. Do I have a bad contact in the switch, right? We can check all those things fairly easily, like at the switch if we need to, or at the window motor itself if we need to, right? It's not that complex. Yeah, there's maybe some body panels you have to worry about, but it's not that overly complex. Then if we look on the 2016 Tahoe, the left rear window switch, if I look at this wiring diagram, I have power, I have ground, but I also have connections to the computer data line system and also the door lock system. So that's in a separate wiring diagram. But the switch has a logic board on it. So now the switch is considered a module. And over this LIN bus, it gets commands and instructions as to how this window motor is going to go up and down. We do have the hardwired switches in there, but we still have data coming back and forth over the network. Now, maybe on the window switch, it's not as much. It'll be just more transmitting than anything. But if there's a lockout at the main switch, that lockout signal will come in over the data line system. So if I have a LIN bus problem on the vehicle, it could be a problem. Speaking of LIN bus, right? So on this vehicle we're looking at, here's my LIN bus line. So network 4. So there's at least 4, and there's more, but in this case, we see up to 4 different LIN buses. So linear interconnect networks, what GM calls it, but it is bus 4, and that is a 12-volt differential network. So you'd see a square wave in a changing pattern to the left rear window switch. So that's really where my control is over this LIN bus. So it sends signals out, sends signals back in. You'll also notice that it shares And we'll look at this a little bit more in detail when we go live on the tool in a minute. But it's not just powers, ground, and relays. It gets a signal from here, then it changes the relay, and then it sends a signal back. You know, all of this happens quickly, but still we have to deal with the different messaging that we're thinking about. And then this is on a Cadillac of the same year. This one has the motor and the switch and the logic board, and everything's kind of just built in all together. So here's the switch right here, and the switch controls this logic board on the motor. So instead of the logic board being on the switch, it's actually in the motor, and then we have a hardwired switch here. So the switch is wired directly to the motor, and it sends a signal. So we have our down signal, our express signal, our up signal. And then we also have a door ajar switch signal. Battery comes in, networking again, computer data lines, and then the ground as well. So it's still powers and grounds, but then we're seeing signal wires as well. And it also goes through another connector. So they get more and more complicated the further up the chain we go, right? So you think a Tahoe and an Escalade, they're pretty similar, but the way they run them and the way they change, they may look similar on the outside, but on the inside, completely different the way they work. So let's go and look at a case study, something kind of real world where we can talk about how we want to change our diagnostic strategy. So in this case study, we have a 2011 Jeep Liberty, and it has a rear wiper. So a customer complains the rear wiper doesn't turn on. Now this is, granted, it's a 10-year-old car, right? So it's not as complicated, but there's still body control modules involved in it. So you think, all right, well, rear wiper doesn't work, so you know it's got to be pretty simple, right? So where are we going to start? Could it be the motor? Sure, motor's not working, something wrong inside the motor. You know, it's got a bad wiper. Fair enough. Is it the switch? That's a possibility too. Switch is in the front, right on the column. You turn it on, you turn it off. If it doesn't make connection, it doesn't work, right? Could be in the wiring harness. Now think about this though, on a Jeep. How much wiring is between that switch, the module, and the rear wiper motor? There's a lot of wiring in there, and it could be a problem anywhere. So what do? Do I just start pulling off door panels, start chasing wires, start chasing that harness all the way down on one side of the car, all the way to the back? Do I lift up the trunk or the cargo compartment, should I say? Take the cargo compartment, drop the panel there, and start checking at the motor? All of that takes time. And we all know that time is money, right? So if I can save time by changing my thinking about how to think about this problem, I can save time when coming to diagnosis. And it's not just for a wiper motor. It's not really even just for body electrical, because we can think this way about engine computers. We can think this way about transmission. It's just this method always stuck with me after I went to Subaru school and they first introduced body control modules at the ripe old age of 2005. Way behind the curve on that. Subaru seems to always be behind the curve on technology. But when they introduced it, that always stuck with me when I went to school, and they said, okay, so now we have a body control. So you don't have to worry as much thinking about relays and wiring and all that. You have data and you have functional tests. So by doing this, we can split the circuit. So why not use our scanner first to narrow down where I need to look on this vehicle? So it could be any of those things, and I agree, it could be any of those things. But I don't want to start pulling off body panels, and I don't want to start chasing wires, and I don't want to go all the way back to the motor. So if we use our scanner, we have two different ways to do this. So first off, of course, we want to scan the car. No codes in this case, but we want to go into the central gateway, or TIPM, which stands for Totally Integrated Power Module. That's what Chrysler calls it. It's kind of like a body control module with a bunch of extra stuff on it. There's relays and fuses in there too. But it's kind of an integrated module, but it's their body control module, at least back then. So if we go into central gate and we see we got codes, we have data, and we have functions. So in this case, let's go to a functional test, and we'll go right to that rear wiper. So by doing this, I can command the wiper to go on or off. Now, if we take a look, it comes with all the data, and that's a lot of data. I don't need to worry about most of this data. I want to trim this down. So on our tools, on our scan tools, we Also have a custom data list function, which I'm sure a few of you use at least. And if we deselect all of them, we can just select the rear wiper and the rear wiper switch, which is all I care about at this time. Go back to my list view, and then we'll see the rear wiper is off and the rear wiper switch is off, which makes sense because I haven't done anything yet. Then all I need to do is just a simple click on the screen where it says on, check off the box, and then we'll see that the rear wiper is on, and we can visually look in the rear and see that the rear wiper is wiping in this case. Obviously, we know that wouldn't always be the case, depending on where the failure is. But in this case, on this case study, you command it on and it turns on. So in a minute and a half, 2 minutes, ID the car, go in, scan it, go into the module, go into functional test, turn it on, and it turns on. So I know at this point, half my circuit's good. And it's the bigger half. I say bigger half, but it's the stuff, it's the circuit with the more wiring. I don't have to worry about anything from that TIPM back to the motor, because that rear wiper motor is working when I command it on. And by commanding it on, what I'm doing is taking over control of this module. So it's like I'm inside the module and I'm sending the command. So it's turning itself on when I do that. So that's a good thing, right? I don't have to check the motor. I don't have to chase down the harness. I don't have to worry about the TIPM even working, at least on the output side, because I've verified my output side. I don't have to worry about that. So now let's use data. Since we use functional tests for the outs, we now can use data for the in. So we can check the input side. So if we go back up a little bit and go to data, and then we can see rear wiper switch, and we can turn the rear wiper switch. And if nothing happens, like it does right here, and it just says off, and nothing happens at all, and I just move it back and forth and it does not change, then I know that module does not see the wiper switch. Now, still could be the switch, could be the wiring, could be internally inside the body control module. Maybe there's a loose solder joint in there or something like that. But at least I can narrow it down. Now I know where to look, because now I know the module is not seeing it. So it helps us verify the input side. Remember how I said we got inputs and outputs, and we got to worry about splitting it in half. So the TIPM's not receiving a signal from the switch. So we do further testing. The switch was found to be bad contact or what have you. It's just not sending the electricity through, right? So it's not making it to the module. So the switch was replaced. Now we'll use the data again to verify it's working properly. And you might say, well, that's kind of silly because you can just flip the switch and it'll turn on. Fair enough, that's true. But by verifying it with the data too, I can at least make sure that everything's working the way it should, and verifying what's in my head, right? So what should be working. So if you turn on the switch, it says it's on, rear wiper says the output's on, my input's good, my output's good, the car's fixed, and I didn't have to spend half an hour, 40 minutes, whatever, ripping body panels off, chasing wires for something I didn't need to do because it already worked. All right, so we can use our scan tool. As long as we have a scan tool with bidirectional controls, that's just about any scan tool that Snap-on makes at this point. So, you know, even if you didn't have a Snap-on scan tool, you can still do it. So verify your inputs, verify your outputs, make sure everything works from the computer, and that'll save you a ton of time pulling door panels and chasing wiring. Okay. So that was kind of the point I was trying to make. Let's save some time by using the tools we have. All right, so let's go live and check a few things here. So let's take that same premise, that same problem. I know I'm sticking with the wiper, but in my mind, that's the one that's the biggest pain in the butt, because I got a lot of harness all the way back, and I got a lot of panels I got to pull off if I don't have power in the back. So by saving myself the time, I'm saving myself tearing down the vehicle, right? So let's go into Job Key, and let's take a look at some wiring, because this is another thing that'll help you out, is if you get good at reading wiring, because then we can figure out how. So let's do this, and I'm going to do the rear wiper. Okay, so rear window wiper. And you see we got TSBs, repairs, component locators. let's just go right to the wiring diagram. I want to see how this one's. Okay, so that's white front, and then we should have the rear right here. There we go. Rear wiper and washers. So pull that up. Pull that up a little bit further. Okay. So here is, let's say I have a rear wiper in up on this. I can see my motor. It's got a logic board in there. It's in the lift gate assembly. So I have LIN bus, I have battery positive voltage, and I have ground. And the motor's kind of all contained, all self-contained. So it's really just a 3-wire deal. I can check if I have power. I can check if I have ground. I also have a connector right here. So just using this wiring diagram, I can see that it is computer controlled, right? Because we got the computer data lines. We still have the power. We still have the grid. So that's fair enough. Check that. But we could check this with the scan tool using the same function we just talked about on the Jeep. But what if I wanted to take a better look at this computer data line system? Click on that, and that'll open my computer data lines. And then I know if I zoom in here, I can find my rear wiper mode. So if I click on that rear wiper mode, we can see it shares a LIN bus with my right rear window switch, and then we have this little breakout here, and there's a splice there. So I can trace that all the way back. Also shares with the left rear window switch. So both rear window switches splice in, as well as the body control module that says that's LIN bus. So we can see that all the way through, and I can see my different connectors that I need to worry about as well, going all the way back. Scroll down here a little bit. So let's say I wanted to test it. I can test this any which way I want to. Using the scan tool helps us narrow it down. But what if I want to check my outputs at the body control mode? So if I wanted to go, that's X2 on the body control mode. So let's see. X2 pin 21. So let's look at the connector. Body control module. There we go. Connector MV. Okay, so it's going to jump me down here to the bottom. There we go. Body control module X2. There we go. So it tells you the different terminal information, tells you the pin numbers, tells you the colors, tells you the gauge, right? So here is light green with gray, local interconnect network serial bus 4, and that is a half gauge, right? Half millimeter. So if I needed to take a look at that pin out, I can see the pin out and blow it up for me. If I wanted to chase it back all the way, you can do the same with the other connectors as well. Let's get this out of here. A lot of data. It's out of there. All right, so we can see even all the way back. So there's the connector there, there's a sub connector there, there's a splice, and there's the other connector at the end. So we have a lot of connectors to go through as well, even just to get back to the rear wiper. So it could have a failure, and any of these points would give us a failure in our rear wiper. So that's my wiring diagram. So I want to see inputs and outputs. And then if we can go over to our scanner, as we had it before, of course, we can go to our body control module and data. And we can see there's separate wiper and washer data in this. Click on that. And then we see I have my ons, off, my commands, and so on. I could go into a custom list if I wish to do so. And then let's see, rear wiper command, rear wiper switch. And then I could just go back to my lists and I can see them there. So active or inactive in this case, intermittent, on, off, etc. This is just dummy data. So of course it's not going to stay static. I'm not hooked up to a car. But you'll be able to see it there. And then of course we could go back to my functional test, same thing. Output controls it would be under. And then let's see, rear wiper there. It's going to give me my data again. I can change my list to my wipers and washer data. And then I could also customize that list as well. Go in here, rear wiper switch, rear wiper command. And then I could see it on and off. Of course, like I said, it's not going to change because we're on a demo car, but that's how you would do it. You turn it on and off, see if the motor works. See if it sends the command. If it doesn't send the command, then we know, or the motor, it does send the command and the motor doesn't come on, then we know we have a problem on that side. Then we can also check the wiper switch at the same time and see if that works. If we have an input on our wiper switch. And like I said, this works on really anything with inputs and outputs. If you think about it, we could do it on an engine, we could do it on transmission. But body, it's really helpful because we have all of those different body modules and so on. So another thing that we can do, other than using the scanner, is we also have it built-in guided component tests on the tools with the scope. So Zeus, Varus, Verdict, Modus, Triton, Vantage, any of those tools will have the guided component test module. So we go in there. Many vehicles also have a body electrical category. So on this 16 Tahoe, for example, we have exterior lighting, horn, power lock system, window controls, wiper and washer system. If I wanted to go into the washer system and look at the windshield wiper motor, it's going to give us information on that. So let's look at the rear again. The rear wiper module controls rear wiper motor operation. Battery voltage supplied to the module is used to operate the wiper motor in all modes and return the rear wiper arm to their park position after the ignition is turned off. We have battery voltage. Accessory voltage supplied to the rear wiper washer is used to supply the rear window wiper and washer switch signal circuits. In wiper switch position 1 and 2, the wiper switch signal circuit voltage level to the wiper motor module determines the wiper motor delay interval, so it's going to be changed. The rear window washer pump supply voltage and the rear window washer switch. Lift gated jar switch signal circuit provides information to the rear window wiper motor module about the status of the lift gate, so that'll be over the network as well. If the lift gate or lift glass is open, the rear wiper operation is not performed, so that's good. So if the glass is open, it's not going to start trying to wipe it. All right, so you can see it's all of a 3-wire connector as we saw on the wiring diagram. Ground, battery positive, and limbo. So best place to test it is at the component. That's actually the rear. So a component connector under the trim panel in the center of lift gate below the window. If I back up, we have a DC voltage test and an outer range no signal test. So DC voltage test, we can see, let's see. So that's the rear window. Battery positive, no good ground. Key on should read battery voltage. Key on, turn rear wiper window switch to on. Should drop to near 0 and wiper switch should run at low speed. So it just gives us our different pinouts, whether we're doing the front or the rear. It's kind of a combo deal on this one. And then let's say the windshield wiper switch. So in this case, we can check. There's different positions, right? Mist, delay, manual, low and high, and wash. And then there's also automatic modes if it has automatic. And there's moisture sensitive wipers as well. So there's going to be a sensor for that. The outside moisture sensor monitors moisture accumulation on the windshield and uses a windshield wiper washer switch status input to provide wipe commands to the body control module. So once again, everything's going in a module. So if I have a sensor that is reading voltage or reading moisture, then it's going to send a command to the module, and the module is going to send a command to the wiper motor. It's going to turn the wiper motor on without any intervention from me. I just have to have the switch in the right spot for automatic. But yeah, it's going to be a lot of networking involved in this as well. So if you want more information on diagnosing LIN bus, probably want to check out our networking class as well. Our park position, it sends back park position. It's low speed operation, missed, and then so on and so forth. So it tells us how to test it, where it's located. It's located in the stop in the steering shaft there. And then it gives us our pertinent connectors. So low, reference, or ground, windshield wiper switch low, windshield wiper switch high, and the washer switch signal in this big connector right there with a bunch of other pins in there as well to perform other duties. And then in this case, it's a resistance test. So between the high speed and the ground, it should be continuity, open circuit, and all other switch positions. And it should read 332 ohms and missed. Let's see, low speed should be 774 ohms, etc. So it's going to vary the resistance depending on how that switch is turned. So we can see all that in there. Once again, it's built right in. I want to check the power locks, same deal. So door lock actuators. All right, resistance or voltage. Door lock switches, voltage. Going to tell us all about how it works. A lot of body control modules involved there too. Lock and unlock, and then we also have the networking connector on there as well. So a lot of information to be had. hopefully the main point I was trying to make with the let's split our circuit in half, use our inputs, use our outputs, so we can narrow down what part of the circuit we're working on. And hopefully that'll help save some time when it comes to especially body electrical. But like I said, works on a lot of different electrical type systems and components on the vehicle as well. So hopefully we took away a few little nuggets to help us with that tonight. So that is it for body controls today. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.